Welcome back for the next lesson on division. Let's go to our thinking question. How do you use multiplication to help you with solving division problems? I think that was pretty evident when we were using the partial quotient strategy or algorithm, because we had to ask ourselves frequently, how many sets of this do I think will go into my dividend? And in doing that, you're really asking yourself what times the divisor will get you as close as you can to the dividend. So there's a lot of relationship between multiplication and division when you're solving a division problem. So like I said, we're doing part 2 of our multi-digit division lesson. And as we're going through this, we're going to be seeing how it's related to the partial quotient strategy, and you'll be able to understand the traditional algorithm, which is a shortcut. So you will be able to solve it more quickly with a little bit less work. So this first one, you're going to pause the video and set it up just like you set up the partial quotient, except you're not going to put that extra long line down there. So you're just going to have the division symbol, and then you're going to put your divisor and dividend where they belong. Pause the video and do that now. So this is what it should look like. The 340 should be within the division symbol, and the 5 should be on the outside. The first thing we're going to ask ourselves when we do the traditional algorithm for division is how many times does 5 go into 3? So we're really asking 3 divided by 5. What does that equal? Well, we don't know because it doesn't have a whole number for an answer. And what I'm really asking is how many times does 5 go into 300, which we could answer. But we're going to work with that later. But this is technically a 300 that we're talking about. This is kind of like with the partial products versus the traditional algorithm for multiplication. We are working with simpler numbers without all these extra zeros, but we're going to get to the same place in the end. We're just taking a few shortcuts. So now I'm going to ask myself, how many times does 5 go into 34? I'm really asking, how many times does 5 go into 340? But we're keeping it simple. So we're asking, how many times does 5 go into 34? Well, it goes in at least 6 times, because 5 times 6 is 30. If I said 7 times, then that would be too high. We can't go over. It's really important that you don't go over. So I'm going to put a 6 over my tens place, because that's the last place value that I was working with. Now I'm going to multiply 6 times 5, because that will tell me how many I'm going to have to take out of my dividend. And so 6 times 5 is 30. So I'm going to put down a 30 and subtract that, and I'm going to get just 4 left over. Now it's not just 4, it's actually 4D, because that's in the tens place value. To represent that, I'm then going to pull down what I have in my ones place, and now I'm going to ask myself, how many times does 5 go into 40? It actually goes in evenly. It goes in an even 8 times, so I'm going to write down that 8 there in the ones place. 8 times 5 is 40. So I don't have anything left over, and I don't have anything left to pull down. Now I've shown you how to do it, and now you are going to walk with me through one of them. So pause the video and write this problem on your paper. As we go through these problems, I would really encourage you to think about how this relates to the partial quotient strategy or algorithm. So the first thing that we're going to do is ask ourselves, how many times does 8 go into 2? It doesn't. So now we have to go to the next place value. How many times does 8 go into 20? It'll go in twice. So because this was the last place value I was working with, I write the 2 above the hundreds place. So it's technically saying 8 goes into 2,200 times so far. That's only part of our quotient. We don't have the whole thing yet. So 2 times 8 is 16. It's really saying 200 times 8 is 1,600. And that makes sense because our 16 aligns with the thousands and the hundreds place. So 20 minus 16 is 4. Now we're going to be working with the next place value. So we're going to pull down our tens place. And we're going to say, how many times does 8 go into 46? We're really asking, how many times does 8 go into 460? Because that's in the hundreds place, and the 6 is in the tens place. So how many times does 8 go into 46? It goes 5 times. 5 times 8 is 40. That's really asking. 50 times 8 is 400, which makes sense because our 4 is in the hundreds place, our 0 is in the tens place, and we have a secret extra 0 there that we just haven't put because, again, this is a shortcut. And then we're going to pull down our 7, and we're going to ask ourselves, how many times does 8 go into 67? It goes 8 times. 8 times 8 is 64. We'll subtract that because now we've put 8 more groups of 8. And we, oh, that's supposed to be a 3. 8 can't go into 3. We don't have anything left to pull down. So we have a remainder of 3. So the answer is 258, remainder 3. All right, we're going to do this one completely together now. So pause your video and write out what this one will look like. So this is what it should look like. Now you're going to pause the video and ask yourself how many times 9 goes into 6. If it can't, then go to the next digit and ask yourself how many times does 9 go into 66. Pause your video and do that now. 9 goes into 66 7 times. So then you have to ask yourself 7 times 9 equals what? 63. Now you're going to subtract that. Pause your video and subtract. The answer is 3. Well, now we have to drag down our next place value so that we can work with that one because we're just working with little pieces of the numbers at a time, but we are making it a shortcut so that it's faster than our partial quotient. So now 9 goes into 33. How many times? Pause your video, figure it out, and then write it above and subtract the number that you need to subtract. So 9 goes into 33 3 times, and that equals 3 times 9 is 27. So we put the 27 down and we subtract that from 33 and we get 6. So I want to point out that the reason we're doing 3 times 9 equals 27 and the reason we did 7 times 9 equals 63 is because we need to see how much of the dividend we're taking away when we have that many groups. So it's saying so far we have 730 groups. So when we did the 700 part, how many did we take away from the dividend when we had 700 groups of 9? And how many did we take away from the dividend when we had 30 groups of 9? So we've left off, we have 6 down here, so we're going to, or technically 60, so we're going to pull down our 2 and ask ourselves 9 times what equals 62? Or how many times does 9 go into 62? And you're going to pause your video and do that now. All right, so 9 went into 62 6 times. 9 times 6 is 54, so when I subtracted that, I got 8. Well, 9 can't go into 8 at all, so that's going to be our remainder. The next one you're going to do completely on your own. 1,233 divided by 4. Pause the video and do that now. So for this problem, this is what it looks like. We're going to have the 1,233 within the division symbol, and then our quotient is going to be 308, remainder 1. There was a tricky step in there that you may have missed and may have gotten a few numbers wrong. When you subtracted 12 minus 12, you got 0. You pulled down the 3. When you asked yourself, how many times does 4 go into 3? You found out none. So that means you have to put a 0 in the tens place above where you just pulled down that 3. And then you can keep going. So 0 times 4 is 0. You subtract that, you get 30 or 3, and you pull down the 3, and you keep going from there. Try this one on your own. Pause the video and solve this now. For this problem, your answer is going to be 931, remainder 4. And if you can follow this here, you can check your work if you didn't get it correct. Let's do one more on your own. Pause the video and try this now. The answer for this problem is 374, no remainder, because we did not have anything left when we subtracted our last number. So it went in exactly evenly. Now let's try a word problem. So Mr. Lee is planning a field trip for the whole school, but they're going to have to drive vans instead of buses. He knows that 7 people will fit in each van. 683 people will be going on the trip. How many vans should he reserve? So we're going to be dividing 683 people into vans that fit 7 people. So we need to find out how many vans we need. So you're going to pause the video and solve that now. So you should have done 683 divided by 7. And when you did that, the answer that you got was 97, remainder 4. However, the question asked how many vans should you reserve? If everybody's going on the trip, we're actually going to need 98 vans. Because if 97 vans is how many we can fill completely, and then there's 4 people left over, that means that we would need another van for those 4 people to go in. It wouldn't be full, but we would still need it. So it's important when you read word problems, especially having to do with division, that you really understand what it's asking, because sometimes you're going to have to figure out something like this where you need to find out if you actually have enough of something. A factory packages tennis balls in containers with 3 balls each. The manager needs to know how many containers they go through in a day. He knows that they package a total of 4,554 balls each day. So if there are 3 balls in each container, how many containers does he need in one day? So we know how many balls he packages and we know how many balls are in each package. So you need to figure out how many containers he needs. Pause the video and solve that now. He's going to need exactly 1,518 containers, and there's no remainder, so we don't have to worry about that. It makes exactly the right amount of tennis balls. So hopefully now you fully understand how the partial quotient strategy works, and also how you can use the traditional strategy or traditional algorithm to help you get to that point a little bit faster. So our thinking question for the next lesson is, how is the long division algorithm related to the partial quotient strategy? So you're really going to have to think back to how you used both of these lessons to figure out how to get the answer. Goodbye.